Hi guys, welcome back. We are going to be talking about section 1.2, which starts off with the product property. And property is for exponents, so it's some special rules we can use. So just as a recall here, remember 10 to the 6th is writing 10 6 times and multiplying it together. And 10 to the 9th is multiplying 10 or 9 tens multiplied together. Okay? So sometimes, particularly in science, you may need to multiply very large or very small numbers, and we tend to write these numbers using exponents. So we need to know how to multiply and divide these numbers when they're written in exponential form. It saves us a lot of time. So if I want to do 10 to the 6th times 10 to the 9th, well, 10 to the 6th is 6 factors, or 6 tens, and then 10 to the 9th is 9 factors of 10, right? So we had a 10 to the 6th times 10 to the 9th. We just wrote it all out. And then if we just multiply them all together, that gives me 15 tens, okay? Now we don't want to have to write out 15 tens all the time, so we write 10 to the 15th, okay? So the question is there a shorter way to get from 10 to the 6th times 10 to the 9th to 10 to the 15th? And there is. So if we look at the numbers 6 and 9, 6 plus 9 equals 15. So if we add the exponents, we can get 10 to the 15th, just like what we did if we expanded it. Now, we can only do this if the bases are exactly the same, so they're both 10 in this case, and we're multiplying, okay? So that's what the product property is. If we're multiplying with the same base, we can add the exponents, okay? We can also do this with variables. So a to the 4th is the same as writing a 4 times with multiplication, times a to the 3rd, which is a 3 times, which gives me a total of 7a. So I'd have a to the 7th. And again, we can add the exponents. 4 plus 3 equals 7. How convenient, right? But again, we can only do this if the bases are exactly the same, so they were both a, and we multiplied. So let's try this some more. So this is the general rule. This is how we write exponent rules, is saying the same base multiplied together, add the exponents. Okay, so let's try this. So 3 to the 6th times 3. Okay, so if I were to write this out, this would be 1, 2, 3, 4, 5, 6 times another 3. Okay, which would be a total of 7. So this throws students off sometimes because there's an invisible 1 here. So we need to make sure when we're using the shortcut, if a number doesn't have an exponent, we automatically put a 1 there. Not a 0, but a 1. So 6 plus 1 is 7. And again, we just keep the same base. So I have negative 4 squared times negative 5 squared times negative 4 to the 5th, I apologize. So I know my base is going to be negative 4, and I have 2 plus 5 is 7. So that would be negative 4 to the 7th. 1.2 to the 3rd times 1.2 to the 4th. Go ahead and try that one on your own for me. So this would be 1.2 to the 7th. Because again, we did 3 plus 4 is 7. And we kept the same exact base going all the way through. Same thing even if there's a fraction, because the base is exactly the same. I know my base is going to be 1/5 of my answer. And then I'm just going to add my exponents. Notice add my exponents, 5. I was correct. Notice my base is not changing. So I didn't do 1/5 times 1/5 is 1/25 over here. The base stayed the same all the way through. Okay? All right, z squared times z to the 6th would be z to the 2 plus 6, which would be 8. Again, remember that when we just have something by itself, this is to the 1 power. So go ahead and try this one for me. And this should be 2x to the 4th. And we want to make sure that 2x is in parentheses because the 2x is in both pieces, okay? Otherwise, we wouldn't be putting the 2 to the 4th power, okay? Same thing with b's. So we would have negative b to the 3 plus 5, which would be 8, okay? Let's go ahead and look at the next page here. We can do the same thing when there's lots of things being multiplied. So here we have b squared times c cubed times b to the 5th times c to the 5th. So we just take like bases. So b squared times b to the 5th would be b to the 7th. And then c cubed times c to the 5th would be c to the 8th. So my final answer is just b to the 7th, c to the 8th. Because remember, there's just an invisible multiplication sign between two variables if there is no other sign. Next one here, if we have numbers in front, we just multiply them like we normally would. So 2 times 3 is 6. And then I'm going to go ahead and look at my x's. So x to the 4th times x squared is x to the 6th. And then y squared times y to the 6th would be y to the 8th, because 2 plus 6 is 8. So my final answer would be 6x to the 6th, y to the 8th. Go ahead and try this one. Remember, we have a 1 here for an exponent, so p to the 1 times p to the 5 would be p to the 6th. And then q to the 3rd and q squared would be q to the 5th, because 3 plus 2 is 5. And again, we just kept the same base all the way through. I hope you have a wonderful day, and we'll talk to you tomorrow. Bye.